Welcome, welcome. Late night recording, here we go. We have AC method for factoring. So what I love about this, and I wish someone had taught it to me back in the day when I learned this, yes, when dinosaurs ruled the earth, because each step you can see where it's coming from the line above it. Factoring to me felt very much like all these numbers float around in your head, roll around, and you keep trying them out in a race and try them out in a race and try them out in a race, and then poof, you have your answer. And there was like no rhyme or reason to it, no logic. It drove me nuts. So this method streamlines the entire process. Every step is reversible. It works on every quadratic that can be factored. I say that because there is the occasion where we get prime. Alrighty, so I've rearranged the order. We're going to work number 7 first because number 5 did something weird that I didn't want to see first. So I want to show you one that actually does the whole thing. So this is 30m squared minus 9m minus 12. Now this one, the directions will say something like factor completely. Whenever you see the word completely with factoring, 9 times out of 10, it is a common factor in all the terms. Factor it out first so your numbers are smaller. We could still work this with the bigger numbers, but if you look, our AC pair is 30 times negative 12 would be negative 360. We can find the pair, it's just huge. These are all divisible by 3, so 3 is coming out. 3. This will leave us with a 10m squared minus 3m minus 4. All right, so AC, we're still finding that perfect pair, but now, instead of just multiply to C, add to B, it has to multiply to A times C. So we are looking at 10 times negative 4 and negative 40. We're looking for the pair that's going to add to a negative 3. So negative 3 is not that big, so these have to be pretty close together. So 1 and 42 and 20, way too far apart. 3 doesn't go into 40, so let's take a look at 4 and 10, or 10 and 4. So negative 4 and 10 would be positive 6. Negative 10 and 4 would be negative 6, still too far apart. So after 4 comes a 5. Negative 5 and 8, negative 8 and 5. And there we go. Those two add to negative 3, so there's our perfect pair. Now, watch what we do with the perfect pair. Just like I showed you in the first one where A was 1, but here it makes a big difference because we're not going to see minus 8 and 5 in our factored form. Negative 3 is the same as negative 8 plus 5. This has an m, so I'm going to write these with m's. This is negative 8m now, or minus 8m, and this is plus 5m. You can swap the order and put the negative 8m with the minus 4. Just you're going to have to factor a negative then and pay attention to it. Now, if this is the perfect pair, then when we do the factor by grouping, we are going to see the same thing in the binomials. If it's not the same, we either made a mistake or we picked the wrong pair. All right, and then I'm going to copy those first and last terms again. And the big giant parentheses still with the 3. That 3 is just going to keep going and going and going. All right. So we're going to focus on these front two, 10 and 8. I can only get a 2 out of those, but I can also get an m. So that is 2m, and then that'd be 5m minus 4. Oh, that sounds familiar. 5m minus 4 up there. And indeed, when we look at those, they have nothing in common. So I'm going to put a placeholder of a 1 and just copy those down. And again, our 3. Now we have the 3. And now you notice the 5m minus 4 and the 5m minus 4. I have those in common. And then I write my leftovers, 2m plus 1. We have a factored quadratic with the 3 up front, so it's not cramping our style. 5m minus 4 and 2m plus 1. So with the a not equal to 1, we still factored it. Just the a times c, we had to consider a few more pairs before we found it. But otherwise, it's the same work. You got to think a little harder up front to find the pair. But after that, it's all the same work. And it kind of checks itself, because if these two binomials are not the same after you factored after finding the perfect pair, then you know you made a mistake and you go back and find it. If when you write down the perfect pairs, like what factors out is really weird, it's like, okay, maybe that pair was wrong. Double check. Did I mess up a sign? So if you see the same numbers, but the sign is messed up, like go back and double check. Was the pair I had up here the correct signs? Are they indeed equal to what was above it? It's just really nice for the way it lines things up. You can see where everything's coming from. It's not just, oh, I had this, poof, I have that. Like when I was in school, those middle two lines never got written down. It was just top, bottom, done. I'm sure some of y'all had the same bad experience. All right, so let's take a look at the next one that I moved because it was being silly. So we have a negative squared term. We don't factor with negative a's. So we're going to factor out that negative. So it changes the signs. What was positive is now negative. And then we're going to figure this one out. So our a times c again, 14 times a negative 2 is a negative 28. And here we go. We got a lot of pairs to consider. We have negative 1 and 28, negative 28 and 1, negative 2 and 14, negative 14 and 2, negative 4 and 7, negative 7 and 4. 5 and 6 won't work. And we are now on to a number that appeared on the other side. So we've checked all the possible combinations. So I went through 1, 2, I skipped 3 because it won't work. This is 28, not 27. Then 4, it's not divisible by 5. If it's not divisible by 3, then 6 won't work either. So we have our full and complete list. And I want you to look. Where's our perfect pair? Right? There is no perfect pair here. Now I want you to pause and think. This could happen on your homework. That is totally reasonable. And this would be our answer, the negative 1 factored out. Or we might even have the option of like prime and Alex for this. They'll probably give you like 1, maybe 2 that don't factor. More likely to see it with the sum of squares that we're going to see next video. Here though, like if you notice the 4 and the 7, if they were the same sign, I could add them and get 11. But they don't subtract to 11. So what would I have to fix in this problem so these guys could be the same sign? So if I wanted to put, here, let me grab a different color. So if I wanted to put a negative here on the 7, those would have to multiply to now a positive 28. And I want to keep the 14 positive, so that means the 2 would need to be positive. Now, normally, like, certainly this is not the kind of thing I would ask you to do on the test, like, where's my typo, fix it. That is the kind of BS that you guys saw on the STAR test, those of you who had to take the Texas standardized test. I apologize for it. It sucks. Teachers hate it just as much as y'all do. But it can be a good learning experience, so that's why we're going to go with it. So if I changed this to a +2, then my perfect pair here does work, and then it will factor out. But as it stands, does not factor. So I'm just going to circle that typo in there. All right, so now that we have fixed it, let us practice. So a negative 4h and a negative 7h. And if you want to write that the other way around, that is perfectly fine. Still with the negative 1 hanging out. It is just going to persist through the whole problem into our answer. All right. So we consider these front two. They're both even, but 4 won't go into 14. So a 2 and an h. And then the leftover is a 7h minus 2. Which is very similar to what we wrote here, just the signs are opposite, which is perfect because that negative 7h, we want to factor that out. We don't leave the negative hanging with the variable term. So we're going to factor out a negative 1. And now this is a positive 7h, and now this is minus 2. Now our uglies match. Ugly, ugly, same ugly, yay. All right, so the negative 1 on the outside. 7h minus 2 and 2h minus 1. Now, if we boxed those back together, multiplied it all out, it would go back to the corrected quadratic, not what was originally typed. All right. So, interesting experiment fixing a typo. Mistakes do happen, but we learn from them. So on a test, if you are ever freaking out, you're like, this is not the answer. This can't be right. This makes no sense. There is a mistake, but my brain can't find it. I am freaking out and it's not going to happen. Like, write that down on your paper. Say, I know this is wrong. Here is why this is wrong, but I'm going to do other things. And that tells me you're at least thinking about your work and evaluating whether it makes sense. That's a big deal. That is a more important skill I can teach you than any of the rest of us. If you hadn't guessed it by now, I'm very opinionated. All right, and now we have 8a squared minus 11ab plus 3b squared. AC method makes this work even nicer. Like before, I kind of hand waved what happened with the variables and just said, oh, it'll look like this at the end. Here, we're going to see it fall out. Like AC will totally take care of it. Now, we are multiplying 8 times 3. And I'm going to write 8 times 3. Why am I just writing 8 and 3? Because it already is the pair. So I know 8 times 3 is 24, but I don't actually ever need to know what the product is. I just need to find the pair. And in this case, the numbers I would multiply give me the pair, except we'd sneak in some minuses. So there we go. So step number 1. We now change this to minus 8ab minus 3ab. And we're going to keep the other terms. Now, there are a number of ways you can factor. I do not care which way you use, as long as you are comfortable with it and it works. So if you want to pop into office hours and say, hey, this is the way I do it, and show me and explain how you work through it, and I say, yes, that should work all the time. If nothing else, I love seeing new methods. All right, so AC, we got it. We found our pair, factor by grouping. The first two, a lovely 8 and an A. And that leaves just an A minus B. All right, now here we have to factor out that minus. They both have the 3, and now they have a B in common. And A, and the minus is there now. So negative times negative would get us back to positive. And so this is what it can look like when you're going to have one of the binomials have a 1 and a 1 for the numbers. It does happen. It's kind of rare, but it does happen. And I just realized I wrote these backwards, but I'm just going to go with it like I totally meant to do that. So we have a minus b is the common ugly, and the 8a minus 3b for our other terms. Negative 3b times negative b would get us back to positive 3b squared. 8a times a would get us back to 8a squared. And the inner and the outer work out as well. So there's our factored form. All right. I have loads of other ways to do this. So if you would like to see a different way, come by office hours and I will show you another way to do it. All righty.